Okay, let's go ahead and pick up where we left off. So that whole process that we looked at in the previous video, finding that instantaneous rate of change using our limit, is what we call finding the derivative of a function. And we write that in a variety of different ways. The most common of which is this, where that's just a little, it's not a 1, it's not an exponent, it's just called a prime in mathematics. So you may have seen something like that when you did translations in the coordinate plane back in geometry. You had a and a prime as a being the original point and a prime being the new point once you translated it. Same kind of idea here. We've got f prime of x representing the derivative of that function. So the derivative of a function is just the instantaneous rate of change for that function. It's the slope of the tangent line. There's a lot of different ways to talk about what the derivative is. And here's the thing, guys, if you're going to take calculus next year, this is where you're going to begin. This is the first part of calculus. It's a building block of calculus. So we talk about it now so that when you get to calculus, it's a little bit easier to understand. There are some other notations, and you'll see these next year if you take calculus, dy over dx, y prime, this notation. We're going to probably stick mostly with using this in the videos that we're going to do. So to find the derivative of a function, we're going to use the limit as h approaches 0 of f of x plus h minus f of x all over h. So the good news is there's not really a whole lot different from what we did last week and what we're talking about right now. So I'm going to give you an opportunity to sort of practice this along with me to find the derivative. So to find the derivative of f of x, we're going to do the limit as h approaches 0 of f of x plus h minus f of x all over h, and then we're going to just simplify that. So I'm going to have you do this in parts here. So pause the video and just off to the side here, figure out what f of x plus h is, and then come back and double check. Okay, so I've written down what f of x plus h is. Make sure that you've got the same thing. And then I'm just going to continue to work through my limit. So the limit as h approaches 0. Now go ahead and let's write that all in. So we've got 3x squared plus 6xh plus 3h squared minus 2x minus 2h minus, and then in the green I've got 3x squared minus 2x all over h. Okay, pause the video, see if you can find out where my like terms are that are going to end up being 0 when we add them, and then come back and check your work. All right, so hopefully you got to here. I sort of highlighted the things that would end up canceling out. I didn't show the step where we would distribute the negative sign, but you could do that and end up here in the same place as well. Okay, now I want you to go ahead and pause, factor out an h from everything in the numerator, and then come back and check your work. All right, so we're just moving along here. Hopefully you see, we've got that giant 1 with our h's, and what we have left is the limit as h approaches 0 of 6x plus 3h minus 2. And now's the beautiful time in the whole process when we can just plug in 0 for h, and we get 6x minus 2. So this is the derivative of f of x. Now I want you to start paying attention, guys. Look at what we started with originally and look at what we're ending up with. So what I want to do is just write, f of x here was 3x squared minus 2x. That's what we started with. Our derivative, f prime of x, is 6x minus 2. Now maybe some of you are starting to, based on what we did last week and what we're doing this week, you're starting to see some patterns and maybe making some conjectures. We're going to get to that in the next video. But for now, let's go ahead and do another one. All right, so we'll work through this together here again. I'll kind of give you some prompts and then have you pause the video at certain points and see if you can do some of the steps on your own. So we're going to find the derivative. And in order to do so, remember the derivative is the slope of the tangent line. So we're going to do the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, pause the video here for a moment and at least write down so we know. I'm going to write over here so I have some room later. I want you to write down what f of x plus h is. Pause the video, come back and see if you got it. That was probably a little bit easier than maybe you thought it was going to be, because that's really all you can do. So this is our f of x plus h. This is our f of x. I'm going to go ahead and substitute in. You do the same, come back and check. So at this point, you're thinking, well, Mrs. Kopp, I can't really combine any like terms and make anything be 0 in the numerator, and you would be right. So we need to actually use our process of multiplying by the conjugate, multiplying by that thing that will create a difference of squares. So let's see if we can remember what that is. We're going to take whatever's in the numerator, and we're going to multiply it by the conjugate. In other words, what would make it a difference of squares? Well, there you have a difference of squares, because you have something minus something and then something plus something. It's the same somethings. And whatever we do to the top of that fraction, got to do to the bottom, because I essentially need to multiply by a giant 1 so that I don't change the value of the fraction. Okay, so now that we have a difference of squares, that's easy to multiply out, because with the difference of squares, we know the middle terms are always going to cancel out. So all I really have to do here is multiply the first terms together and multiply the last terms together. So when I multiply the first terms together, I have square root of x plus h times itself, which is really just squaring it. So when you square a square root, they're undoing functions, they're inverses of each other, which means you're just going to end up with x plus h. And then we're going to take square root of x times square root of x, which is square root of x squared, which is just x, and it's going to be minus x, because it's a positive times a negative, all over h. Okay, great. Oh, not all over h. I almost did exactly the same thing that you guys would probably have done. It's over h times, don't forget we multiply by, right? So now in the numerator, we see this x minus x is going to be 0. So what we're left with is the limit. I'm going to move this up here. The limit as h approaches 0 of h over h times the square root of x plus h plus the square root of x. And then, the whole point here is you should get that giant 1 so that you get rid of your h's altogether. Now, at least your h as a factor in the denominator. That leaves you with a 1 in the numerator still. A lot of people here forget about that and make their mistake there. What's great is that we're now at the point in the process where I can just plug in 0 for h. So what I end up with is the limit as h approaches 0 of 1 over the square root of x plus 0 plus the square root of x. And we don't even need the limit anymore there because we plugged in 0. So let me get rid of that. This is just actually now evaluating for the limit. And that's just the square root of x plus the square root of x. Now, a lot of you might leave it that way, which would be fine, but this actually will allow us to eventually see some more patterns. So what I know is that if my original function was f of x equals the square root of x, I have now figured out that the derivative of my function is 1 over 2 times the square root of x. So my answer is this. But again, I'm trying to show you the original function as well, because we're going to be looking for patterns. Okay, head over to Classroom and do the Google form. And as part of this process, I want you to be paying attention to the patterns, because in our last video for the week, we're actually going to talk about a shortcut that we can use to find the derivatives.